All right, guys, this is actually take 2, so I'm gonna try and go quick here. All right, so we have a problem. You toss the ball up into the air and catch it at the same height 3 seconds after it was released. And I want to know what was the ball's maximum height. This is a great example of what we talked about very briefly at the end of class, which is a symmetry problem. Okay? What I mean by that is that the ball thrown up ends up at the same place, same height. If that's the case, start and end, and at the same height. If that's the case, it's called symmetry because the time for it to go up is equal to the time down, which are both equal to 1/2 the time total. Okay? So, the nice thing about that is that means we can split this problem into parts. We can do the up part and the down part. So what do I know about each? Well, T up is going to be 2. It's going to be half the total time. Oops, it's supposed to be 4 seconds. I'm sorry. 4 seconds later. Okay? We know acceleration is negative 9.8. And we know that V final for the up part is 0. For the down part, we also know that T equals 2, A equals negative 9.8, and V initial actually for the down part is 0 because it's starting at the top and falling down. Now, it turns out we're not going to need the down part at all here, but I just wanted to point out what those values were. All right, so now that I've got this, I can go ahead and solve for change in x. That's what I'm looking for. But I can't do it directly. Oops, not 0, question mark. All right. I don't have the right numbers to get change in x immediately. So instead, I'm going to find V initial. So I'm going to use V final equals V initial plus AT, which is 0 equals V initial minus 9.8 T, or times 2. We know what T is. And that gives me V initial is 19.6. With that, now I can use change in x equals V initial times T plus 1/2 AT squared. It's going to be equal to 19.6 times 2 minus 4.9 times 2 squared. This comes out to be 19.6 meters. All right, so that's a symmetry problem. Symmetry, again, just means that it starts and ends at the same height. Okay? Start height equals end height. And that tells us that the time up equals the time down equals half the total time. All right, I'm going to ask Tom to pause here so you guys can work on problems number 11 and 13. Okay, so hopefully you've got 11 and 13 down. So now we're going to talk about a slightly different problem. All right, the difference here is that instead of catching it at the same height, we're going to catch it 1 meter below and 3 seconds in the air. Okay? So instead of it looking like this, we have it looking like this. Start in the end. Oh. And we're going to say let's hit the ground. The ball. And it hits. Hits. Ground 1 meter below 3 seconds after it was released. Okay? So, this right here is 1 meter, and it's starting the end. Now this is not symmetric. Oops, there's the bell. So I'm at the hustle here. But we can still break it into parts. There's up, down. In this case, we're also going to consider the overall, the whole piece, whole path. So for the up part, you know, acceleration is negative 9.8, which is true for all of them. We also know that V final for the up part equals 0, V initial for the down part equals 0. We don't know what V initial is for the whole part. Okay.
I was just confused. I have this class next, right?
Yeah, I know.
Okay, yeah, go ahead. You
Something.
can, yeah, you can play.
It's all right. It's all right. Let's go, Wallace. He's messing it up again.
Ah, jeez.
Such a bummer. Sorry, I actually videotaped it once, but I screwed it up and I missed like the top half of it. So I'd already done it once. Sorry, guys. Anyways, the initial we don't know. Nor do we know B final for this.
Hello.
That's okay. We do, however, know time for the whole part is 3 seconds. We don't know what it is for either up or down because it's not symmetric, and so we can't divide it by 2. We also know one more thing. Oops, so we don't know time. Change in x. Change in x. We know that change in x is -1 meter. So even though we don't know what it is for up or down, we can know what it is for the overall. You're fine. Don't worry about it. All right. However, we do know that the initial for the whole thing is the same as the v initial for the upward part. Okay. All right, because again, we think they start at the same place. The upward trajectory starts at the same place that the whole trajectory starts. So if I can find this, I can use it in the upward part to get the answer. So I'm going to go ahead and solve for that using the whole path. And I'm going to use change in x equals v initial times t plus 1/2 at squares. Hey guys, sorry, I know I'm in the way. -1 equals the initial times 3 minus 4.9 times 3 squared. You gotta take my word for it that the initial is 14.4 meters per second. So again, I put that here. And now I can do just the upward part. And I'm gonna skip really directly to the answer here. If I use, again, the change in x equation, okay, and we get change in x equals 10.6. So that's not the answer. It's close. It's not the answer. That's actually just this right here. And I want to know what the ball's max height above the ground is. So I have to do one little thing. I have to add 1. And that'll give me the overall height. So the actual answer is 11.6. All right, guys, sorry about the end of that. I had to do it twice because I messed up the first time. Now we're running a little out of time. But I'll have a great weekend, and I'll see you on Monday.
See you later.